Functions, page 3. For each of the graphs of the functions a through d, write down the domain, the range, the points where the graph meets the x-axis, which would be the x-intercept, the point where the graph meets the y-axis, which is the y-intercept. Okay, so let's look first at A. It looks like a line segment, a line which ends at these 2 points, so it's not like a line that continues. So I would say that the domain looks like it's going from -4 to 6. The domain, remember, is the x interval. So it looks like -4 to 6, right? We would write that by writing -4 less than or equal to x less than or equal to 6. Okay. Let's see, the range. The range looks like it goes from y equals -4 to y equals, looks like um, about 1, right? 1. So it would be from -4 less than or equal to y less than or equal to 1. Okay, what about the x-intercept? I kind of didn't mean to mislead you here, but the x-axis is actually here. Okay, so where does the line cross the x-axis? Looks like at x equals 4. So that would be x equals 4. What about the y-intercept? The y-intercept, the y-axis is this line here. It crosses at y equals -2. Okay? All right, now let's move on to B. B is a parabola. Looks like it kind of goes on forever. You see, it doesn't have these little points like A has. So looks like the domain would be all the real numbers. Okay, and then the range would be all the numbers. No, so remember the range is the y interval. So looks like it's anything 8 and below. So that would be y is less than or equal to 8. Okay, and then the x-intercept. The x-intercept would be negative. Looks like the x-axis is right there, right? So it looks like it would be -4 and 0. So -4 and 0. Those are the two x-intercepts. Y-intercept would be, there's only one y-intercept, and the y-intercept happens to be right there at the same point that there's an x-intercept. It's also at 0, the origin. Okay. What about C? C, do you see how it has these little dots here? So it has these little dots here. That means it kind of like ends. It doesn't continue. So the domain looks like it ranges from, or the domain looks like it's an interval from -1 to 1, right? So -1 less than or equal to x less than or equal to 1. Y looks like it ranges from 1 down to 0. Looks like 0 to 1. 0 to 1. So 0 less than or equal to y is less than or equal to 1. What about the x-intercepts? Looks like it touches at -1 and 1. There and there. So -1 and 1. What about the y-intercept? The y-intercept would be at 1. Okay. What about D? The domain for D looks like it ranges, or it looks like it's an interval from -1, and it looks like it kind of goes on forever, right? There's no little dot to indicate that it stops. So I would say -1 less than or equal to x, and then it just goes on forever, so I don't need to say what the maximum is. The range, which is the vertical interval, looks like it goes from there to infinity. So it would be about 4 to infinity. So we don't need to say what the maximum value is. The x-intercept looks like it does not have an x-intercept. It never touches the x-axis, so nothing. Y-intercept. It looks like it crosses the y-intercept at the value of 8. So I'm going to put 8 here. Okay? So that was a very thorough analysis of these 4 graphs. We don't know what the equations are for the graphs, but we don't need to know them. Just by examining the graph, we can figure out the domain, the range, x-intercept, and y-intercept, right? Okay. Moving down to number 3. Decide whether these statements about the functions drawn in question 2 are true or false. Okay, so we need to go back and look at each one again. First thing it says, for function A, which is the line segment, point 1, -1 lies on the graph. 1, -1. So there's 1, and there's -1, and no, that point does not lie on the graph, so that is false. What about the image of x equals -2 is 0, so that means that the y value when x equals -2 is 0. -2, 0. Is that a point? -2, 0. No, it's not. When x equals 6, y equals 1. Now that is true, right? Because when x equals 6, y equals 1, that's that point right there. Okay. Function B. There are 2 values of x for which y equals 8. Looks like there's that point and there's that point. So there's x equals -4 and x equals 0. X equals -4 and x equals 0. There are 2 values of x for which y equals 4. Yeah, that's true. Actually, we don't need to say what they are, and thank God, because that would be kind of hard. We could just say it's true, okay? There is a value of x. See, that would be like this point and this point, which are not exactly whole numbers in terms of x. So that's why it's good that we don't have to say exactly. There's a value of x for which y equals 9. And that looks like it's not true. Do you see how like the maximum value is y equals 8? Y equals 9 is off the graph, so no, that's not true. Moving on to function C, which is the half circle. The line x equals 0.5 intersects the graph of this function twice. So x equals 0.5 would be this line here. It intersects the graph once, actually, so no, that's false. Then it says the line y equals 0.5 intersects this graph, the graph of this function twice. Y equals 0.5, and that is true. Intersects twice, right? True. The image of x equals 0.2 is the same as the image of x equals -0.8. Okay, let's try that out. -0.8 would be about here, and x equals 0.2 is about here. Now, if you see what the y values are for these 2 points, are they the same? No, they're not. So, if they said positive 0.8 and negative 0.8, then those would be kind of reflections of each other. Those would have the same y value. Positive 0.2, negative 0.2 would also have the same y value, but 0.2 and negative 0.8, no, they're completely different. Function D, the line y equals 1 intersects the graph of this function once. Y equals 1 would be about there. It would cross the y-axis at 1, and no, it doesn't intersect at all. When x equals 16, y equals 1. When x equals 16, y equals 1. No, when x equals 1, y equals 16. It's the opposite. Okay, when x equals 16, y is like a very big number. As the values of x increase, so do their corresponding values of y. Well, that's true. Like if x increases, y is also increasing, right? True. Okay. Last part. Sketch a graph for each of the functions below. Okay, so first of all, I'm gonna make the axes in blue. And so A, I know that the y-intercept is 3, and I know that the slope is 2. 2 over 1, 2 over 1, 2 over 1. Okay, so there's my graph right there. Okay, what about B? I know that the y-intercept is 2 and the slope is -1. So let me draw my axes here. And my y-intercept is 2 and my slope is -1, -1, -1, -1. Okay, looks like that. Finally, this one here. The slope is 3 and the y-intercept is -4. Y-intercept is -4, so it intercepts about here. And then the slope is 3, which means it rises 3 for every 1 of run. Okay, so about like that. Okay, and that was it for number 4. So that was it for page 3.